Python is one of the hottest programming languages right now, with an ever-growing community of developers worldwide. Python is especially popular in fields like prototyping, data science, and machine learning. But it's also picking up pace in web development and embedded systems. In this video, I'm going to tell you why you should learn Python as a hobbyist, student, and even as a seasoned programmer. Welcome. I'm Cons. I got a master's degree in computer science and currently work as a graduate research assistant where I use Python on a daily basis. Python is an interpreter-based programming language initially created by Guido van Rossum in the late 1980s when he worked at the Dutch research institute Centrum Wiskunde en Informatica. He initially intended to use Python as a programming language for the distributed operating system Amoeba. After a year of development, Van Rossum and his colleagues decided to release Python under the MIT open source license because they thought Python would be useful for not only Amoeba. And this allowed programmers worldwide to extend the Python programming language. And in the last decade, Python became very popular. The core ideas of Python are written down in the Zen of Python, or PEP20, which includes the following statements. Beautiful is better than ugly, explicit is better than implicit, simple is better than complex, complex is better than complicated, and readability counts. You can actually see all the statements in the Zen of Python if you import this into one of your Python scripts. Another big goal of the Python community is to keep the language fun, which is even reflected in the name, which is derived from the British comedy group Monty Python.
Your arm's off! No, it isn't.
One crucial part why you should learn Python is it is easy to learn. If you already got a background in programming languages like Java, C++ or C#, Python won't take you longer than a week. But if you don't have any background in programming, Python is incredibly easy to learn and a perfect start. This is due to Python's syntax, so the code you write, that doesn't include a lot of complicated things like these. Together with an easy syntax comes clear semantics, which means what the code does that you have written. If you write your Python code in a certain way, it can actually be understood as plain English when read out loud. Another critical factor why Python is so easy to learn is that you don't have to compile it like languages as C++ or Go. Those languages have to be compiled first with several complex command line commands before you can see your program in action. Python is an interpreter-based language, which means that the Python interpreter, which is a program itself, is responsible for executing your code. Together with being an interpreter-based language comes great portability. So if you want to send your Python code to a friend or coworker, you don't have to give them compile instructions. You just send them the code, and if they have the Python interpreter installed, they can probably run your code without any issues. The list of fields that employ Python as a programming language is long and still growing, and makes another vital point why you should learn Python. The most important fields that use Python are data science, machine learning, web development, and even embedded systems. First and foremost is data science and visualization. For example, the package Pandas allows you to easily manipulate and analyze your data. It can read several different structured file formats like HDF5, CSV, XML, or Excel files, which are commonly used for storing scientific data coming from measurements and observations. And Pandas provides you with several methods to get a quick overview of your data. Take for example this code. Here we are downloading the Iris dataset from GitHub, which is a common pattern recognition dataset for testing, and we're storing it in the Iris variable. Pandas then provides us with the head and the describe methods, and when we run this code, we can see that the head gives us the first 5 rows of our dataset, so we can see how is our data structured. So we can see we have 5 columns, and the head presents us with the first 5 rows. With describe, we can look even deeper into the data. For example, we can see the count, so we have 150 rows. We can see the mean value for every column, we can see the standard deviation, we can see the max value. And there's a lot more methods in the Pandas package. The next package I would like to highlight is NumPy, which allows you to efficiently work with multidimensional arrays and gives you a lot of operations to work with vectors and matrices. For example, here we have a quick NumPy program which does a matrix multiplication. So first we are going to define our matrix, which is a 2x3 matrix over here, as a multidimensional NumPy array. And then we want to multiply it with a 3x2 matrix, which we can also describe with a multidimensional NumPy array. And then we just use np-matmul-ab, which does the matrix multiplication. And when we run it, we can see the result is a 2x2 matrix as we would expect. And if you want to visualize your data, the packages matplotlib and Seaborn give you excellent tools for making professional plots for your publications and presentations. Seaborn is actually based on matplotlib, which further shows the interoperability of Python. I actually prepared a quick matplotlib example, which also uses NumPy. So first we are going to create a NumPy array, which includes values from 0 to 5. Then we're going to store it in the variable x, and then we're going to create a function. The function is called y, and it uses NumPy cosine and NumPy exponential, and we're going to multiply those two. And we can see that we use the variable x, which is the NumPy array we just created. And this creates two arrays with x and y values for a plot. Then we go further and create a plot with matplotlib, and we just call plot, enter x and y, and add a label, which is a damped oscillation. And when we run this code, we can actually see a damped oscillation over here. Closely related and heavily influenced by the field of data science is machine learning. Turning the vast amount of data available to us today into knowledge to guide decision-making requires algorithms which can adapt themselves to the ever-changing world. Machine learning provides methods to make sense of the never-ending stream of data. Over the last decade, machine learning became an essential tool for academia and businesses. And Python is at the forefront of this development with packages and APIs, which makes it incredibly easy to implement, train, and deploy machine learning models. For classic tasks like regression or classification, the scikit-learn package provides a great toolset. For example, if we would like to do a linear regression in a two-dimensional space, we just use the linear model from scikit-learn. We define that we would like to use a linear regression, and then we store that into the model variable, and we call the fit method and give the fit method the points we would like to fit. And this will produce a linear regression. And if we run that, we can see that it also produces the intercept and the coefficient. And when we use those, we can actually plot it like this. And we can see we have this linear regression, the red line, and the 5 points we have entered before. If you want to classify high-dimensional data like complex time series, images, or sounds, deep neural networks are the state of the art. And the frameworks PyTorch and TensorFlow in Python allow you to easily describe neural network architectures. And you don't have to write your own GPU or OpenCL code to train those networks, because those frameworks come with GPU backends already. Take for example this PyTorch code over here, which I got from ChowDAO on GitHub, which describes the famous LeNet-5 architecture, which is used to classify the MNIST datasets of handwritten digits. We can see all the layers defined here in a very clear manner, and we just chain them together, and with that we are going to describe our deep neural network, and then we can later on train it on our GPU. After a neural network is trained, you usually want to deploy it. And if you want to deploy your network on a server with a high-end GPU, you can stick to the frameworks TensorFlow and PyTorch, because they provide excellent performance for those kind of hardware. However, most neural networks these days aren't deployed on servers. They're deployed on embedded devices which have strict power requirements because they run on batteries like smartphones, intelligent sensors, or even watches. And for that, you need specialized code, because they have special accelerators to execute neural networks. And the CUDA and OpenCL code will not run on those. For this, you can use the Tensor Virtual Machine, which is another package implemented in Python, which helps you to optimize your neural networks for those embedded devices, and even helps you to generate code for those devices. To sum it up, with Python, you can build complex machine learning models, train them efficiently, and then deploy them on different devices. And you don't have to learn any other programming language or set up different development environment, because everything is enclosed in one Python ecosystem. Having a website or web service is a must these days if you want to bring your product to the customer. For a long time, web backend frameworks have been dominated by PHP and ASP.NET, but lately Python is making huge waves in the web development world. You can actually set up a simple HTTP server with the built-in Python package Simple HTTP Server. So over here we have the HTTP server and socket server imported, and we create a simple HTTP request handler. Then we open up a socket server on the port 88, and then we are going to start the server and it will print out the current directory which we are in. So if we run that, we can see we started the server on 88, and if we open the browser and go to localhost 88, we can see it lists the current directory we're in. But you can take it even further. With packages like Django or Flask, you get a rich tool set with which you can build a whole web application completely built on Python. For example, take this Flask Hello World over here. We're going to import Flask, then define a Flask app, and our web server will respond with Hello World if we access the root directory. So if we run that on the command line, we enter Flask run, and then it will open a web server on port 5000. So if we have a look at our browser over here and go to localhost 5000, we see that it actually responds with Hello World. And you can even build web-free blockchain-based applications with the Python package web-free. So if you want to add a web version of your current program, it is actually super easy and you don't have to switch gears. You just use the built-in Python functionality or use a package like Flask or Django to deploy your web service. Coming from an embedded systems background myself, I was first pretty critical of Python because I was used to work with languages like C or C++, which gives you complete control of your environment, but also come with a lot of problems like memory management. The Raspberry Pi gave Python a huge boost in popularity due to its affordability, accessibility, and its vast library of examples written in Python. Due to this, a lot of people started to pick up Python as their first programming language. However, Python still runs on the Linux operating system on the Raspberry Pi. But there have been advances over the last couple of years to bring Python to bare metal, with projects like MicroPython and CircuitPython. If you don't have strict power and timing requirements, you don't have to write C code to achieve your goals. If you just want to read some button presses and display some data on a display through the I2C or SPI bus, MicroPython can do that for you. I actually prepared a little MicroPython command over here, which we can run on the Raspberry Pi 2040. And in this example, we are going to let a LED blink. We first import the machine and the UTime packages, and then we set the pin 25 as an output pin. And then we have an endless loop which sets the value of the LED to 1 or 0 and sleeps for 1 second in between. With this rich environment of different packages and APIs, Python becomes a great language for testing and prototyping. If you, for example, want to develop a web application that does advanced data analysis, you can just couple Flask and scikit-learn to build that, and together with Python's great portability, this prototype can be sent to others to try it out. Especially in an agile software development environment, quick turnaround times and prototypes customers can actually use are crucial for the success of your product. Now that we have seen for what you can use Python, the question is, who uses Python? According to the 2020 HackerRank Developer Skills Report, Python is the second most popular language among hiring managers looking for candidates, and it is only slightly behind JavaScript. And in Stack Overflow's 2020 Developer Survey, Python is in first place for the most wanted language by developers. Python has been adopted by many big companies such as Instagram, which uses Django for their web framework. Instagram's developers put a big focus on simplicity and practicality, and they even praise their web framework for its scalability and efficiency. Another big player is the music streaming service Spotify. They use Python mainly on the backend for their recommender and data analysis systems, which are composed of many different services. Another well-known streaming service is Netflix, which heavily relies on Python on its backend. The most prominent example of Netflix's use of Python is Chaos Gorilla, which is a service that constantly simulates losses of critical infrastructure to test and improve the reliability of Netflix's services. Last but not least is Dropbox, which even went that far to hire Guido van Rossum, the initial creator of Python, from 2013 till 2019. Because Dropbox uses Python everywhere, from their front end to their back end and to their web services. Everything is Python. The list of Python success stories is very long and proves that Python is not just a language for prototyping, testing, or for beginners. Some of the biggest tech companies run their businesses on Python. To sum it up, you probably interact with a service that is written in Python on a daily basis. Python developers are in high demand. Python ranks amongst the most sought-after programming languages in 2021 due to its use by leading tech companies and its big open source community. An entry-level Python developer can earn up to $65,000 per year according to Dex, and a Python expert can easily make 6 figures annually. And those are the reasons why you should learn Python. It is easy to learn and comes with an insane amount of third-party packages for almost every use case. The code is platform independent and can run on virtually any system. Python is relevant and growing in almost every sector, and even as an entry-level developer, you can earn a decent salary. So now is the best time to learn Python to kickstart a new career or take your current career in a new direction. I'm actually launching a Python course together with a computer science course here on my YouTube channel, so make sure to subscribe and hit the bell icon that you don't miss it. And if you want to catch up with me, join our lovely Discord community of computer science and programming enthusiasts. Big shout out to my Patreon subscribers for their support. And if you want to know how to run multiple Python versions on your system, check out this video over here. I wish you a fantastic day and hope to see you in my next video. Bye bye!